Okay, so hopefully you should have finished your quick check. So to write the KC expression, okay, make sure that you put your products as the numerator, all right, and the reactants, put it as your denominator, all right. All of them are raised to the power of their respective coefficient. So you see sulfur trioxide, there's 2 moles here, you will raise it to the power of 2. All right, so for its unit, you just actually follow the expression that we have in our KC, and we're just going to cancel out whatever is repeating. All right, so if we cancel out these two, because they are exactly the same, we will actually be left with per mole dm cube. All right, because mole per dm cube, when you actually multiply by power of -1, you will get per mole and dm cube. All right, so if you're going to write this expression in Kp, then this is the expression that you're going to get. Notice that when you are writing for Kp, right, your partial pressure, you're going to put it in round brackets rather than square brackets, right? So that's something that you might want to take note of. And also there is a partial pressure alphabet, all right, in addition to the compounds that you're writing down, okay? So otherwise, it is the same as Kc. The units wise, we're going to use ATM since the question actually told us that pressure is given in ATM. All right. So on to our second example. We're going to do the same for our expression of Kc and the units. All right. You notice that the units actually just nice cancel out, right? So you cancel one, and then you cancel the next part. You're left with no units, right? So same thing for Kp, we're going to basically just do the same. And you realize that the units for Kp cancels out just as well. Okay, so when the equation is reversed, the Kc unit is actually the reciprocal. What do I mean by that? We mean that whatever value that your Kc, whatever expression, beg your pardon, whatever expressions that your Kc has, right, the reverse reaction is going to basically just be 1 over your Kc expression. So if you look at this, basically it's just flipping it around. All right? Simple, huh? Okay, so moving on to homogeneous equilibrium. When we say all the reactants and product are in the same phase, it means that it is a homogeneous equilibrium. All right, then every species in this particular system will be included in the expression. All right, so check out this example. Okay, your propanoic acid and your ethanol, your ester, and your water are all in liquid phase. All right, so all of them must be in your Kc expression. So what this means is that water, right, is not treated as a solvent. It is instead treated as a product. All right, so next up we have heterogeneous equilibrium. Actually, homogeneous literally means same. Right? Heterogeneous means different. Okay, so when the phases of the reactants and the products are different, this is what we call a homogeneous equilibrium. All right, so for this kind of equilibria, the concentration of pure solid and liquid are excluded from our expression because their concentration doesn't change. All right, if you think about it, right, like a solid piece of wood, right, if you take away one part of the wood, the rest of the wood, right, has the exact same concentration as before. All right, so for heterogeneous equilibria, we do not include the solid in the expression. All right, so for this word example, you realize that your Kp is simply just your partial pressure of carbon dioxide. Same for your Kc. All right. Okay, so again, it is quick check time.